Hello, everyone. This is Dr. Wen. This problem looks not easy. Can you solve this problem in 1 minute? First question is, find the probability of x less than y less than z. Second question is, find the probability of phi of z less than 0.2. What are those x, y, z's? X, Y, Z are normal 0 to 1, IID, random variable. Normal 0 to 1 means normal with mean 0, standard deviation 1, IID. This I means independent. This identically. This is distributed. So, independent, identically distributed random variables. Phi is the normal 0 to 1 CDF. CDF means cumulative distribution function. Now here is the first question. We want to find the probability of x less than y less than z. So here, we know that all three random variables have the same distribution and independent. So all orders of x, y, z are equally likely because that's symmetrical, right? X, y, z, all they have the same property. Same distribution and independent. So here the total number of orders is 3 times 2 times 1 equals 6. What does this mean? For example, x less than y less than z, this is one kind of order. We can swap x and y less than x less than z is also another kind of order. So all these kind of orders are equally likely because those three variables are IID. So now, what kind of variable we can put in the first position? 3 variables, you can pick one. So that's 3 possibilities. After you fix the first location, how many random variables you can select to put here? We only have 2 random variables left because you already fixed one here. So you have 2 possibilities. After you fix 2 locations, you only have 1 variable left you put here. That's only 1 possibility. So total number of orders equals 6. X less than y less than z is just one of those orders. They are equally likely. So what is the probability? Probability should be equal to 1 over 6. 1 over 6 is the answer for the first question. Let's move to the second question. We want to find the probability of phi of z less than 0.2. First of all, we need to understand the notation. Notation looks complicated. Phi is what? The CDF, cumulative distribution function. It is a probability. So here, because it is a probability, which one is the random variable? This one is the random variable. Cumulative function, usually that's a number, fixed number. But here you can see the function variable here is capital Z, not a constant. Capital Z is a random variable. So the whole thing, phi of Z is a random variable. So probability of this random variable less than 0.2. Now here, what is the distribution of this? Looks like we don't know. So how can we find the probability? Look at here, inside the part, we take inverse function on both inequality. So here, because CDF function is increasing, you keep the same order when you take the inverse. So take the inverse here. Now we have random variable here. That's the inverse function of the CDF. So what is the definition of this? This is the probability cumulative distribution function. That's the cumulative function, that's phi. What's the random variable? Z here, right? What's the CDF for Z is also phi. So here, this can be replaced by phi. Phi of the inverse phi. We can cancel each other. That's 0.2. That's the answer. Now, here we have a very important result. So what is this? Phi of Z actually is a random variable. What kind of random variable? That's uniform 0, 1. That's uniform from 0 to 1. It is a very important information. This result is a fundamental thing in Monte Carlo simulation to generate random variables. It is very important. If we know this is a uniform 0, 1, so from very beginning, we know that normal uniform 0, 1, random variable less than 0.2 equals 0.2. That's uniform. That's all. Thanks for watching. See you next time.